transforming exponential and logarithmic functions. Before we start applying transformations, let's go ahead and look at the parent functions, or some of the parent functions, for exponential and logarithmic equations. Okay, on this first one we have y equals 2 to the x. This is an exponential equation, and if we fill in this table with its values, we're just raising 2 to different powers. So 2 to the negative 3 is 1/8. 2 to the negative 2 is 1/4. 2 to the negative 1 is 1/2. Anything to the 0 power is 1. 2 to the first power is 2. 2 squared is 4. And 2 cubed is 8. So notice we have a 1 in this middle, and then we have the 2's, and then the 4's, and then the 8's. This little pattern there. Okay, so then let's go ahead and plot these points. Okay, there we go. And notice that these points over here, you kind of have to start estimating when the fractions are getting really small, with an 8 or a 4th, anywhere in there. Afterwards, it'd be a 16 and a 32nd, but this is good enough. Okay, so for the domain, we can raise 2 to any power. So the domain for this is all real numbers. But the range is not all real numbers. In fact, let's look. Okay, so if we're moving on our table or on our graph from the right to the left, so we had 8, 4, 2, 1, a half, a fourth, and an eighth. We're dividing by 2 as we go. So we'd have a 16th, and then a 32nd, and then a 64th, and so on. Well, the numbers would get really, really small, but they would never actually reach 0. You can't take something and divide it by 2 and get 0, unless, of course, that were 0 itself, but that's not what we're talking about here. We're just trying to figure out, is 2 divided by a certain number equal to 0? And that's not true. So all that's to say is that even though the numbers will get, or the y values will get really close to 0, they will not reach 0. Reason being is because we've got, well, what that causes, in other words, is this horizontal asymptote. And it's this invisible line that we don't graph, but I'm just showing you here, that the graph will approach really close to, but it will not cross. There's just this boundary right there. So that is called an asymptote. And so the equation for this horizontal line, which happens to be on the x-axis, is y equals 0. And then the range, of course, looking at this, are all of the y values that are greater than 0, so that'll be y is greater than 0. It's not going to be equal to, because we can't be equal to it because the asymptote is at 0. So the range will be the y values greater than 0. So if you know this 2 to the x and how to get all of its information, it's actually pretty easy to find the next couple of examples that we're looking at. For example, log base 2 of x. So 2, it's still our base, but this time we have the inverse of an exponential is a logarithmic equation. And so our base is still 2 here, but let's see what happens. I'm going to fill in this table of values with this. I have an 1/8, a 4th, half, 1, 2, 4, 8. Okay. So for each of these, I'm saying log base 2 of 1/8 is equal to our y value. Let's pick an easy one to start out with. Okay, what is log base 2 of 2? What exponent do we put on 2 to get itself? Well, anything to the first power is itself. How do we get from 2 to 4? What exponent do we put on this base of 2 to get to 4? Well, 2 squared is 4, and 2 cubed is 8. And anything, if we are looking for log base 2 of 1, if x is 1 right there, anytime that number is 1, doesn't matter what our base is, that y value is 0. And so you'll see that this, when we fill in the rest, if you compare the exponential function with the log, the x and the y values are switched. And that is because these two things are inverses of each other. So let's go ahead and graph these points. Alright, so there we have the log base 2 of x graph. Okay, now looking at this graph, you may be able to see that just like before, there is an asymptote, but instead of it being horizontal, it is now vertical. right? So this time, our range is going to be all real numbers. Our asymptote is at x equals 0. And the domain are all of the x values greater than 0. So with inverses, the domain and the range will switch, and with the asymptote, it will switch from the horizontal to the vertical. And if you compare these two graphs, they are the same graph, just remember they're reflected over that line y equals x. So if you compare these two graphs here, you can see that this bottom one is a reflection of this previous graph over that line y equals x. Okay, so let's look at if we have a different base. Instead of 2, let's look at 1/2. Okay, so let's look at the exponential equation 1/2 to the x power. So again, we're looking at an exponential. So 1/2 to the negative 3, so that's the same thing as 2 cubed, and so we'll get 8. 1/2 to the negative 2 is the same thing as 2 squared, so that's 4. 1/2 to the negative 1 is 2. Anything to the 0 is 1. Anything to the first power is just itself. 1/2 squared is a 4th, and 1/2 cubed is an 8th. Let's graph these points. Alright, there we have it. It looks a whole lot like the previous one of 2 to the x, except instead of it swooping roughly saying that direction, it's been reflected over the y-axis, and so now it's going the other direction. Okay, you also can notice that with the y values, even though the x values stayed the same, the y values are just going in reverse order. You can think of that in whichever way you like as far as how you want to remember it, but this is how we got that graph. Okay, the domain for any exponential is going to be all real numbers. And then let's figure out if we have an asymptote somewhere, which we do. I'm going to just sketch it in again. So you can see here that it's that horizontal line of y equals 0. So for any parent function, by parent I mean it hasn't moved left or right or up or down. For a parent exponential, the asymptote will be at 0, and it'll be a y equals. If it's log, it'll be an x equals 0. Okay, and then the range here, clearly on our graph, is all of the y values greater than 0. And then on the log functions, they should look quite similar, right? Because now we know that logs and exponentials are inverses of each other. So now that we know 1/2 to the x, we can just switch the x and the y, and we'll have our new table. And you will be responsible for knowing these values, or at least how to find them. Okay, and let's go ahead and plot these points. Okay, so for any log function, we know that the range is going to be all real numbers, that the asymptote is going to be an x equals, and here again that's still at x equals 0. It's getting close to this line, but it will not cross it. So that'll be x equals 0. And then my domain is quite clearly x is greater than 0. Okay, now let's apply some transformations. Okay, so for these two examples, these are number 1 and 2 on the worksheet that you'll be getting in class. You won't have the graphs on it. You'll have to do it on your own paper. But you can also print off or copy down the problems, and then you could start doing them on your own paper and follow along as we do these two examples. Alright, so on number 1, we have f of x is equal to 2 to the negative x minus 3. Let's first of all describe the transformation. Remember, we always describe the horizontal first and then the vertical. So this negative in front of the x, that means that it is reflected over the x-axis, I'm sorry, y-axis. And then also this minus 3 tells us that we're going to go down 3. So what we're going to do is take each of our parent points, reflect them over the x-axis, and then go down 3. Now for these, if it's helpful for you to put the parent points on there and then transform them, That's one way that you can do it. Just for the purposes of this video, I am going to just sketch in the parent points, and then we can apply the transformations to each point. Okay, so I went ahead and applied the parent points here. I'm going to take each one, reflect it over the x-axis, and then go down 3. So I'll start with these smaller ones. So I'm going to reflect it over the x-axis and then go down 1, 2, 3. Same thing here with this -2, 1/4. So I'm going to reflect it over and then go down 1, 2, 3. Those are all going to be smushed together there. The half, reflect it, go down 1, 2, 3. The 1, reflect it, go down 1, 2, 3. At 2, reflect, go down 1, 2, 3. The 4, reflect, go down 1, 2, 3. And then the last one, reflect, and then go down off of the screen. Go down. Oh, do we not have enough room here? Not quite. Just stopped with the screen. Okay, so, and this does make sense. It got reflected over and then it got shifted down. So there's our graph right there. Oops. All right, so let's check out the domain range and the asymptote. Okay, the asymptote is, since this is a exponential function, that means we'll have a horizontal asymptote. So it's approaching the line y equals -3. So notice our parent function had the asymptote y equals 0, but then on this one we went down 3, and so now it's at y is at -3, which means the y values are going to have something to do with the -3, but just double check what we're talking about here. We reflected it, so here the y values are going to be less than -3, and for all exponentials the domain is all real numbers. Now let's check out this number 2, which is a log function. So we have 1/2 times log base 2 of x minus 3 plus 4. Okay, so we will be going, first check out the left and right stuff, or the x values. So this -3, remember it's the opposite for the x values. -3 tells us that we're going to go to the right 3, and I'm going to abbreviate a little bit here because I don't think I'm going to have enough room. So I'm going to go to the right 3. And then y values, you do multiplication and then addition or subtraction. So this 1/2, we're going to multiply the y values by 1/2. Or in other words, we're going to vertically compress by a factor of 1/2. And then finally, we will go up 4. Normally, I would write that all out, just so you know. So I can definitely see what's happening there. Okay. So let's again, I'm going to put on the graph all of the parent points. Okay, there are my parent points for my log base 2 of x parent log function. All right, so again, I'm going to go through each of these points, apply the transformations in the order that we wrote them down, since we wrote them down in the correct order. So let's start with this one over here at 8, 3. So I'm going to go to the, maybe that was a bad idea. It's not going to fit on there off of the graph. So we're going to go to the right 1, 2, 3. We're going to vertically compress it by 1/2. So we're going to take that and divide it by 2. So now we're at 1.5, and then we're going to go up 4. 1, 2, 3, 4. Okay, so that one's off the graph, but let's do the next one. So here we have 4, 2. So we're going to go to the right 1, 2, 3. Vertically compress it by 1/2. So go from 2 to 1. And then we're going to go up 1, 2, 3, 4. The next one, we have 2, 1. So move it to the right, 1, 2, 3. Vertically compress it by 1/2. So now that we're at 1/2, and go up 1, 2, 3, 4. We're at the point 1, 0 now. And we'll go to the right, 1, 2, 3. Oops. 1, 2, 3. Vertically compress by 1/2. Well, it has a y value of 0. So 0 times 1/2 is still 0. Then we'll go up 1, 2, 3, 4. We have the point 1/2 -1. So move it to the right, 1, 2, 3. Vertically compress by 1/2, and then up 1, 2, 3, 4. Now we have a 4th -2 to the right, 1, 2, 3. Vertically compress by 1/2, up 1, 2, 3, 4. And you can see where our graph is now. Okay. All right, so you could probably see where the asymptote is on this graph. It's where the little cluster of points, where the points are getting really close together, that eighth and fourth and half, where all of those go. All right, so our asymptote here is at x equals 3. Now, logs have vertical asymptotes. I kind of remember that by the letter L on the log. Looks like a vertical line, so I know it has a vertical asymptote. I don't know if you like those little tricks or not, but that's how I remember it. So I knew there was a vertical asymptote, so it was at x equals, and so it moved to the right 3. Therefore, my asymptote also moved to the right 3, and is now at x equals 3. This also means that my domain will have something to do with 3, and it didn't get reflected, so here it is still greater than 3. All of my x values are on the bigger side of this asymptote. And then the range for any log function is all real numbers. So there are 2 examples to get you started on the transformation problems. If you have any questions, let me know, and I will see you later. Bye.